Okay, here we are at our drill press, and we're going to take a second and make some observations about the tool. We can see, if we look closely, that there is a motor that is arranged to be above the work surface, and that, like all of the tools that we've looked at previously, there is a spindle that comes off of that motor, and that spindle then is turning, and in this case that spindle is what is holding the cutting tool, which is our drill bit. There is a lot to learn about all the various types of drill bits, but for now just know that for our handholds on our Apple box, we'll be using a type of drill bit called a Forstner bit. And when we look closely at the Forstner bit, we can see a similar situation as we saw with our blades on both our table saw and radial arm saw and miter saw, in that there is this flat sharp edge section that is a little bit like a snow shovel. And when we look at that aspect of our Forstner bit, we can start to make a prediction about which way the bit will actually turn by looking for the action that the little snow shovel will take into the wood. So you should be able at this point to predict that this bit will be turning in this orientation. And whether you want to call that clockwise or counterclockwise depends on whether you're looking down on the bit or up at the bit. Most of us are looking down at the bit, so I would call this clockwise. And then what we're going to do is we're going to put the bit into what's called the chuck of the drill press. And to illustrate that, I have here a cordless drill that you may be familiar with, and we can see more clearly the parts of the chuck, and that includes these three little kind of flattened triangular shapes that are called the jaws, or actually I'm not sure that they're called. I'm blanking on what they're called right now, but these three parts of the chuck move in and out in order to hold the drill bit in place. So we're going to open up the chuck on our drill press, and to do that I rotate this part of the chuck clockwise, and that opens up those three jaws. I put the bit in between the jaws, and I'm going to start to close it by turning it counterclockwise. I need to make sure that the bit does not go all the way up into the drill press chuck. I want to have the bit be just ever so slightly down from as far as it can go, and I keep tightening that in place. You can see I holding the chuck and kind of turning the collar against that rotation, and then I'm going to complete that tightening action with what's called the chuck key. And to do that, I just put that in and then turn it to the right, and I'm going to put a fair amount of pressure on that chuck key to really lock that bit in place. And then I'm going to be absolutely certain to take the chuck key out of the chuck and put that back over here. If I leave the chuck key in the chuck, when I turn the tool on, that key will fly out and hit me in the chest, and it will be quite painful. So I make sure to remove the chuck key before I get started. But before I do my drilling, I'm going to do that thing that I always do when I start working with an unfamiliar tool, and that is turn the tool on and off really quickly to make two observations. Those two observations are, what kind of power does this tool have? And I hear a pretty good roar out of this drill press, so I have some sense of how powerful it is from that. And then the other thing that I'm doing is I'm making a prediction about what, or checking in on my prediction about what way the bit turns from the power of the motor. And as we predicted by looking at the cutting edge of the drill bit, the bit does in fact turn clockwise as I'm looking at it in this orientation. And that is going to be important for me understanding how both to control the power of the tool, and then also to make some predictions about what might happen if my workpiece binds to the bit as I'm cutting. So I can imagine that if the workpiece binds to the bit, that it will follow the direction of force that the the motor is giving to the tool, and that would mean that my piece would also turn, as we said, clockwise as we're looking at it this way. And when that happens, if I have my workpiece extended out to the right of the drill bit, that means that the workpiece will rotate out and potentially hit me or kind of, just startle me, honestly. So what we try to stay focused on when using the drill press is using the workpiece, holding the workpiece to the left of the bit, so that if the workpiece does bind to the bit, when it does the rotation, it pushes up against this fence that I have in place, and that helps keep the piece solid and steady, and does not create a dangerous situation. So just to call your attention to that fence is basically just a piece of wood that's been clamped down to this table. It serves the same function as fences at all of our other tools. It's another surface for my workpiece to be supported against while I'm doing the operation at hand. So one of the things that is really important in all of our fabrication processes is the idea of feed rate. And what feed rate says is that there is an ideal amount of pressure that we give to either the tool or the workpiece when we're doing an operation. And that ideal amount of pressure will lead to the cutting tool being able to do its job perfectly. In other words, we want to have not too much pressure or not too little pressure. We want to have not too fast of a feed rate or too slow of a feed rate. We want to find the perfect feed rate. And with the drill press, we have a really good opportunity for a visual indicator for the ideal feed rate, and that is these big beautiful chips that come out when I'm giving just exactly the right amount of pressure to my cutting tool. This is a especially beautiful example. The chips should be large and sort of curly. If I have a lot of just plain sawdust that are little tiny bits like that, that may be an indication that I am not using a fast enough or strong enough feed rate, that I need to add more pressure. So let's take a look and watch for feed rate and watch for the size of the chips that come out as I drill this last hole.
Nice chips.
Nice chips.